As a result, the spiders can indirectly reduce greenhouse gases over the Arctic and keep the region cooler than it would otherwise be. The paper shows so well how difficult it is to predict the impact of warmer temperatures on a given community. So says Sarah Gilman, a biologist at Claremont McKenna College in California, who studies the environmental effects of climate change. But until researchers know why the wolf spider's appetite is changing, it will be difficult to project the results of a small experiment onto the entire region. The wolf spider of the Lycosdae family is one of the most abundant and dominant predators in the Arctic. They have around 80 times more body mass compared to gray wolves in some parts of Alaska. Their main prey is the 3-inch springtail, which they pursue and then ambush. The antenna-equipped insect, in turn, eats soil-dwelling fungi, which release powerful greenhouse gases such as carbon dioxide and methane when they feed on decaying plants and animals. To examine how spiders could affect the climate, Amanda Klotz, a biologist at Washington University in St. Louis, Missouri, along with her colleagues, set up a camp in Toolik, Alaska, at the base of the glacier-filled Brooks Range Mountains. She marched over muddy moss hills, avoided huge mosquitoes, and worked on the Alaskan summer's 24-hour daylight schedule. It reminded me of the land before time. Over the next few weeks, researchers collected hundreds of wolf spiders from under rocks and tree trunks and placed them in 30 1.5-meter experimental ring enclosures. A heating chamber was installed in half of these enclosures, which increased the temperature by around 2 degrees Celsius and mimicked the effects of a warming climate. Different parcels also had different numbers of spiders. The team let nature run its course for 14 months and then returned to see what became of these experimental ecosystems. Klotz hypothesized that more spiders would mean fewer springtails, and that also applied to the enclosures with normal temperatures. But within the artificially heated rings with above-average numbers of wolf spiders, there were also above-average numbers of springtails. It led to fewer fungi, less decomposed plant material, and theoretically, less greenhouse gas emissions, the team reports today in the proceedings of the National Academy of Sciences. Klotz suspects that when large numbers of these territorial spiders are around, as happens when temperatures rise, they more often compete, fight with, and eat each other, as well as other spiders that prey on springtails. All this infighting may free up the springtails so they can munch away on soil fungus, preventing the gas-releasing breakdown of organic material. While it is unclear exactly how much gas is bound this way, the sheer numbers of wolf spiders, springtails, suggest that this changing predator-prey relationship and its impact on soil degradation could act as a buffer against warming in the Arctic. Much more research is needed to find out exactly how big this buffer is. Everyone loves to hate spiders, she says, but they play an important role in our ecology.